Okay, so I wrote this next one out while the previous one was uploading, so you don't get to listen to me write it out, but I will talk about it. So we're supposed to find the transfer function V out over Vn, and that's h, and find the frequency omega naught at which h is purely real. So we'll do nodal analysis here at VO. So VO minus VI over R1 is our first term, and then write these J omega L minus J over omega C and R2. So VO over J omega L, VO over minus J over omega C, and VO over R2 equals 0. Alright, so then now split this one up into VO over R minus VI over R1, and add VI over R1 to both sides, so to bring VI over R1 to this side. And then that leaves with the VO over R1, VO over J omega L, V over minus J over omega C, so bring the omega C up to the top. So omega C VO over minus J plus VO over RC. Now, my goal with this was to be able to factor out a VO because I want to get VO over VI. And so I factored out a VO from all of these, and I think that was all I did. Yeah, and so I'm left with these terms here. And then on this next step, what I did was I brought, 1 over J is the same as minus J, so you can always bring a J that's in the denominator up to the numerator as a minus J. So I did that on this term. I brought that J up as a minus J, and then I brought this term up as a minus J, and it became a plus J. So that's what I did there. And then I got a common denominator, and the common denominator is going to be R1, R2, omega L. And so what this first term needed was the omega L R2. So I multiplied this one. I multiplied everything by omega 1 R by R1 R2 omega L over R1 R2 omega L to get the common denominator. So this first term picked up an omega L R2. The minus J picked up just the R1 and the R2 because it already had the omega L. The J omega C needed everything, so it got R1, R2, omega L, and the 1 over R2 needed just the R1 omega L, so it got that. And so then I had that big fraction on this side times VO over VI over R1, and then I'll multiply both sides by R1 and divide both sides by VO, and when I do that, the R1 cancels out of the denominator here, and this V out cancels, and then I realize that, and I get this fraction, but then I realize I have it upside down. I need VO over VI, so just flip the whole thing upside down. And when I do flip the whole thing upside down, I separate out the real and the imaginary parts, because I'm going to need to rationalize the denominator. And so the real parts are the omega L R2 and the R1 omega L. So omega L R2 and R1 omega L are the real parts. And I factored a J out of the imaginary parts, so I have minus R1 R2 plus omega squared R1 R2 and an L and a C. And then to make it, I would end up with the same answer if I didn't do this, but this was to make it look like the page where I had my answers. I multiplied by J over J, and so what that did was it added a J to the numerator, and then the real part became the imaginary part, and the imaginary part got multiplied by a J, so you got a J squared, so the signs changed. So then I had J R2 omega L over, and then from the real part, which is the old imaginary part, I factored out an R1, R2, and was left with 1 minus omega squared LC. And from the imaginary part, I factored out an omega L, and I was left with R2 plus R1. And then to find where it is purely real, I needed to rationalize, so I multiply by the conjugate of the denominator, which is the same as the denominator, but with the sign of the imaginary part changed. So R1, R2, 1 minus omega squared LC minus j omega L, R2 plus R1 over itself. And when I do that, I can just distribute this j R2 omega L through, and so I get the j times, so I multiply the imaginary times the imaginary to get the real. So j times j is minus 1 times the minus becomes a plus 1. And then I get omega squared, because I have omegas in both of them. I have an L squared and R2, and then R1 plus R2. And then when I multiply the j R2 omega L times what was the real part, R2 is squared, so I get j R1 R2 squared omega L and 1 minus omega squared LC. And then when you multiply by the conjugate, what you get is the real part squared plus the imaginary part squared. And now to find out where this is completely real, you take just the numerator and just the imaginary part, set it equal to 0. R1 R2 squared omega L times 1 minus omega squared LC equals 0. So we get, from this part, we get omega equals 0. That's trivial, so that's not useful. From this part, 1 minus omega LC equals 0. Omega squared LC equals 1. Omega equals the square root of 1 over LC. And isn't that what we just found a moment ago? It sure is, yep. So it is still the resonant frequency for a parallel RLC circuit.